There we go.
Hey, skewed aspect ratio.
Hey.
Okay. We all set? Everybody good? All right. All right, so what I was saying, it's an organized set of data. The key word is that it's organized. The computer's gonna be able to go through this and find everything that you need in a programmatic fashion so that you're not stuck doing the data retrieval. A lot of people in here might not think they need a database if they want a game, but you might end up getting stuck writing your own analysis tools. If you're gathering statistics on how people are playing, when they're logging in, if they've finished a certain level, that's stuff you're going to want to keep in a database. You can even drive games off of the database itself. And a lot of the benefits that you get out of a database is that someone's been doing this for 30 or 40 years. Relational databases have been around since the 70s, and all this stuff has been solved. One of the benefits of using a database is a segmentation of duties, both from a programmer perspective and from a hardware and software perspective. If you are making a game, you might not want to deal with all of the ins and outs of dealing with databases. You can give that off to somebody else. If you have a server that's running your game, you don't want your game to start taking a hit when the database starts slowing down because of more users getting in or that whatever. Also, one of the benefits of the database is that it enforces data integrity, meaning you're going to define a bunch of rules on what can go into your database and what's not going to go into it, and it will stop bad data from getting in to begin with. Out of the box, most databases are scalable. This is both for speed of the database and the amount of data that it can process and store and handle. Most databases have some kind of level of fault tolerance. If your server goes off in the middle of a transaction, there are logs that will be able to bring you back up without you having to run backups every 5 minutes, 10 minutes, 15 minutes, or whatever. Another thing that you can do with a database is that you can have multiple users in working with the same data at the same time. If you've ever had to program something like that, it's a pain in the butt. So someone else did it for you. We've got some acronyms you guys are going to need to remember when you're looking up databases and stuff. You don't need to have them memorized, just be familiar with them. CRUD is create, read, update, and delete. These 4 operations are performed by all databases. When you look at libraries that source databases, they'll usually have a section for CRUD operations that say this is how you put data in your database, this is how you change data in your database, this is how you get data out of your database. Another one to remember is ACID. It's atomic, consistent, isolation, and durability. These are 4 characteristics that people have deemed important for your database to be able to do for it to be a successful database. Atomic means when you're making changes to the database, all those changes go in at the same time or nothing goes at all. One of the examples of this would be if you are transferring money from one account to another. When it deducts money from one account and it fails to put money into your other account, you don't want it to just say, oh, you're out $300. You want it to be able to go back to its original state. Consistent is that whatever data is going into your database doesn't violate any rules for the database that you've defined. Whether it be you requiring phone numbers to be in a certain format, or you saying people have to be of a certain age. It could be just about anything. Isolation. If I'm in the database and Jamie's in the database and we're both trying to update the same data, whatever I'm doing first, if I get in, is what takes priority over Jamie. And if I repeat that operation over and over and over again, it should result in the same activity. So it's not I get in there, I get half of my changes in, Jamie gets in, he gets his half of the changes in. It's like Atomic where it's all or nothing. And durability is the durability of your database, being able to survive faults, crashes, unexpected outages, that stuff. SQL, which is going to be a big thing tonight, is structured query language. SQL is a language that was written back in the 70s by IBM, and it is the foundation for relational databases today. In the 90s, it became an ANSI standard, and I think somewhere shortly after it became an international standard. So every relational database that you use that is SQL compliant will all work roughly the same. But everyone has their own variants on it. SQL is broken down into two different types of instructions. You got DDL, which is data definition language, and that's what you use to define your database and set up your tables and everything else, all the rules. And DML, these are the commands that you're going to use to get data in, get data out, and clean it up and things like that. All right, so there's two main categories of databases. You have relational, which is what we're talking about tonight. These are all very similar because they're all standards based. The big market leader is Oracle. They own Oracle Database. They bought, who owned Java a few years back? Sun, yes. And with that, they got MySQL. They have dozens of other databases beyond this. If you've got Microsoft Office, you might have had access to Access. Or if you had an old computer, you might remember Lotus Approach. These all do about the same thing. Two interesting ones that are on this list. SQLite is a database that runs on just about every platform. It's a very small footprint. I think it's built into Android, it's built into iOS. So if you are looking to do some kind of app development where you need access to a database on a mobile device, you have access to that. And MariaDB, not too familiar with it, about as familiar with it as I am as MySQL, but it is a fork of MySQL. A lot of people don't like Oracle, so when they took over MySQL, they branched it, and a lot of the developers that were on the project switched over to MariaDB. Something to think about if you don't like Oracle. I'm fine with them. The other category of databases is NoSQL. These are not relational, but they are so varied that it's hard to say what these consist of. There's different database technologies that Google have developed, that HP and Amazon have all developed, and they all work a little differently. Google's Big Table is a key value lookup, so it's essentially a two-column database that is really fast and distributed over a very wide network. I don't get too much into NoSQL stuff, so depending on what you're trying to do, might be good for you, might not be. A lot of these don't have the same ACID standards that relational databases did, or at least up to a couple of years ago. A lot of these are advancing very quickly. You probably won't need them unless you're working with terabytes worth of data. So. All right, and just a heads up on what WAMP is, AMP, MAMP, or whatever you guys have downloaded tonight. It is a combination of Apache, MySQL, and PHP. Apache is your web server. Chances are that if you are developing a database and you want to use it with your game, you're not going to be deploying that database with your game. So you're not going to have everyone with their own little local database doing their stuff. You're going to have something on the network or on the web or somewhere where your game is interacting with the database. You could do that with Apache. You could do that with Node.js, any other server-side technology that you can send out data with. MySQL is the database we're going with tonight. I'm going to try and keep everything as database agnostic as possible because how MySQL works is slightly different than how Oracle works, is slightly different than how all the other ones work. So, and the server-side scripting for PHP, this works with Apache. It helps you build dynamic web pages, lets you connect to your database and spit out stuff on an HTML page. As most of us found, it's easy to get set up. Were you able to get yours on?
Yeah.
Okay. All right, and also LAMP is still the de facto standard if you are going to a web hosting company and getting services from somewhere. You, a lot of times, will get a MySQL database and PHP and Apache, or MySQL and PHP at a minimum for free. If you're looking for more advanced stuff like Oracle or Node.js or other services, you'll pay on top of those. But this stuff you can usually get for free. Now with that out of the way, relational databases. What is a relation when we're talking about relational databases? It's a relationship between entities, it's a relationship between objects, it's a relationship between data types. Depending on what your background is, you may call it different things. We're going to be using a very boring but very accessible database, allrecipes.com, for a quick example when we're building this stuff. This came out of a database. You have a recipe for crusty white bread. Very boring. All recipes have the same characteristics. It's got a name, it's got a rating, it's got an author, a description, it's got your cook times, it's got ingredients, and it's got directions. And ingredients and directions are their own subset of categories. When we're taking these and putting them in the database, we're going to create a table. A table is the basic storage unit for a database. If you want to think of it, it's like a file cabinet. I hate to use analogies, but for a database, this is very accurate. If you have a table, you can just throw data in. When you want to get data out, if you just have a table, it goes through it line by line, looking for the data that you want. Tables are two-dimensional structures made up of columns and rows. In the examples that we're going to be using, like recipe name would be a column, description, author, all the timings, and each row will be its own individual recipe. Now, if we want to take the file cabinet analogy a little further, some databases support partitions, and what that is, it is a physical breakup of the table that will let you store certain types of data together. So what happens is you define a partition key, which is just going to be one of the columns or multiple columns in your database, and it's going to say everything with the same value from this column goes to the same section in the table. So that way when you're going through and you say, I want to find all the Ford cars, it starts here when it looks and it ends here. You also have the option to do indexes. I don't have an analogy for what an index would be other than a list of all of the things that you're looking for in the database. If we did an index on the car maker like this, essentially you'll have a list off to the side that says you can find all the Toyotas here, here, and here. You can find all the Fords here and here, and Nissans here. The advantage of partitions is that this is done at the database level or at the table level. So when you start scanning, it knows where the hard stop and the hard end is. If you're trying to use an index, first it has to read the index and say, all right, this is the value that I want. And then it has to go start searching through the table to get the rows out that it wants. You can have one partition per table usually. Some databases let you sub-partition columns. So if you had Toyota or you had a car manufacturer as your partition key, you could sub-partition on car type so that RAV4s and whatever SUVs go into the same place, and coupes go into one, and sedans go into another. You don't have the same limitation with indexes. You can define as many as you want. If you want to be able to find unique combinations of maker and model and car color, you can create one and it will point you to those data elements. Another big thing for databases or the table is constraints. These are all the rules that we're going to define what makes up valid data in our database. The first one is data type. It's not officially a constraint, but when you create a column in a database, you say that this is a number of a certain length, this is a character of a certain length, this is a Boolean value, And once you've defined that, you can't put in data types that don't line up with that. You might be able to stick a number and a character, but it will convert that number to a character first before it puts it into the database. Each table should have a primary key. A primary key is an index that will uniquely identify each row. If you're developing a list of users, it could be a user ID, it could be the user's email address. Not necessarily something you want to use, but we'll get into more details on that later. A unique key is very much like a primary key. It also identifies unique rows, but you can have multiple per table, and they're allowed to be blank. So in the case of a primary key, everyone needs to have a value for that. For a unique key, no, not everyone needs it. A foreign key is an index on a table that points back to a parent value. Now, what I mean by this is if you have the recipe table and you have the instructions table, the instructions will point back to a recipe. This foreign key is what that relation, or where that relationship is defined. And we'll get into these a little more in detail. Check constraints. You can explicitly define what you want to be valid values. If you have an age column and you don't want people in there with an age less than 5, you can define a rule that says don't let people insert data with 5-year-olds. You can define as many of these as you want. When you're inserting data into your database, it runs a check against all these, and if it violates any of these rules, it spits an error out back at you and says, try again. Null constraints. Nulls are fun to work with in databases because each company deals with nulls a little differently. Nulls are blank values, essentially. You have to define in most databases whether or not you want a column to be null or not. And how those databases handle that can be very different because null is a pain in the butt. Null is not a value. Null is the absence of a value. So when you try to use it and you start looking through stuff in your database, you can't use that field. If you try to do any comparisons to null, null is not greater than or less than or equal to anything. It is not true and it's not false. If you try to add or subtract or multiply anything to a null value, you get null. And if you're doing any aggregates, it won't include nulls in your values. We'll get into aggregates more, but if you have a table that has 100 scores in it and half of them are null, and you say, give me the average score, it's only going to compute the average over the half of the data set, or half of the rows that have the data. So it might skew your results a bit. All right, so we're going to talk about some data normalization. If you read a database textbook or you check the Wikipedia entries for data normalization, you're going to see a lot of mumbo jumbo. I remember reading this stuff in class maybe 15 years ago. You don't have to have it memorized. If you've got the spirit of the intention, that's fine enough. If you were given some data to build your recipe database, and they essentially just look like this, where you have all of your recipe level stuff over here, and they gave you a list of ingredients here and a list of directions here. This is not what you want to just stick into a database. Ideally, you want every column to have an individual value. There's a rule for these. It's the COD normalization formats. The first rule is to never have multiple values sitting in the same field. Sorry, computer's going a little haywire. So what we would do is we would take this and you'd split it out so that way each column does have its own value. So now we have 4 rows and everything has its own spot. But this doesn't really make any sense. Why would you repeat the same information over and over again? And what does 2 cups of flour have to do with mixing? Or 8 ounces of water? There's no relationship between this data. So what you're going on to do is start splitting this stuff up into things that make sense. In our case, we're going to be taking the recipe stuff, which is all basically header information off of that recipe that we saw. We have the ingredients off to one table, and we have the directions off into their own table. For this example, bread is the primary key on this table. So if someone comes in and tries to insert another bread recipe, it will say you can't put more bread in the database. Or you could make the primary key name and author so that only Dingo can only insert one bread, and then I can go and insert my own bread. But Dingo can't put two things of bread in. This primary key is repeated down here as a foreign key in these other tables. So it says this flour is for this recipe for bread. This water is for this bread recipe, and so on. We've also, if you've noticed, broken out the ingredients into their own separate fields. Databases are stupid, just like computers. It doesn't know anything about quantities and measures. If you want to be able to have your database convert 2 cups to whatever the metric version is for cups, you're going to have to build some kind of conversion. If you want ounces to grams or tablespoons to grams, all this stuff you have to kind of figure out how to do. And you can't do that if all the data is packed into the same field. So what we do is we take the ingredient, we take the measurement value, and we take the quantity, put that in that table. For the ingredients, or for the directions, it's a little easier. It's just an ordered list. It says the first thing you got to do is mix, the second thing you got to do is let it rise, and the third thing you got to do is let it bake. And you also notice that we've taken hours, minutes, and seconds out of prep times and cook times. What you're going to want to do is standardize on one value for all the fields. So if you have 25 minutes for one field and you have 2 hours and 50 minutes, convert the 2 hours and 50 minutes to minutes. So everything's the same. All right, so this is one step further. You'll notice that we've started changing things around a little bit. We've put a recipe ID on here instead. If you had bread as the primary and foreign key everywhere, what if someone wanted to go in and rename the recipe? Now you're updating it in one table here, you're updating it 4 times over here, you're updating it 3 times over here. When you have a primary key that is subject to change, you're better off just using a randomly generated sequence. So if you are building a game and you want users and you think that they could change their email address and that's what you're using for a login name, you don't want their email address to be their primary key. You'll want a sequence to be their primary key that you can go in and change the email address as needed.
Excuse me.
Yes.
What do you mean by sequence?
A sequence. So for MySQL, you can define a column as auto increment. And what that is when you put in a value, it automatically assigns a value. When you put in the next row, it assigns a new value, and it just kind of keeps incrementing. In Oracle, they're called sequences. It's an object, and it's just a number. And when someone goes in and uses it, it gives them the value, and then it increments itself. So a sequence is just it's an incremental value that keeps going up as you use it. And if I gloss over anything, let me know, because I'm looking at this through the lens of 12 years of SQL stuff, so I just assume people are mind readers. And
Isn't that in MySQL it's called auto increment?
yes.
And I think it's in Oracle it's called
Yeah. Yeah, in MySQL the auto increment, as you said, when you define the column, there's a field that says you can make it auto increment. But for Oracle, you have to create a sequence object, and then you put code on top of that when you insert data into the database, it uses a trigger to go in and read the sequence, put in the value. I was going to say maybe it changed recently, but no. You could, I think in the newest version of Oracle, you can do things a little differently than you could before. You can set a default value for a sequence now where you didn't used to be able to, but I don't want to get into the weeds of too much with that stuff. Just so you know, the sequence or primary is just a value, a randomly generated value.
Yep.
It doesn't even have to be incremental, just random value that doesn't overlap. All right, so This gets us down to roughly what we want our relational database tables to look like. If we wanted to expand on this even further in the future, this author could be split out into a user table. So this would be a primary key or a foreign key into another table that gives you all the author information. You could break out ingredients to another nutritional data source. So if you wanted to see how much protein, carbs, and fat was in flour for the recipe that you're making, you could link to another database. If you wanted to be able to convert your stuff from US to metric, you could combine your units of measure and your quantity as your units of measure to another database that has metric just conversions. But we're not going to go into that today. You can see how quickly you can take a database and start quickly looking for other things and start tying out to other data sources. All right, so now we're going to start getting into the boring stuff, if it wasn't boring already. To create a table, it's a simple statement. It's create table, name of the table, list of the columns that you want in it and their attributes, and a primary key that you're defining. You don't have to memorize this. If you go into phpMyAdmin, or if you have MySQL Workbench and you are using the non-web version of this. Something that I'm not going to go over into real deep in this. You may want to create a new database today, sorry. The way that MySQL is set up, you can have multiple databases running inside of MySQL. There isn't a blank demo one to work with, so if you click new and just put in a database name, tvgs demo. I already have one for tvgs demo, so I just blah, blah, blah. You don't have to set a collation value. What this is, it's more nitty-gritty. It determines how things are sorted when you try to organize your data. You can change it around, it doesn't matter. So once you create your table off to the side, you can expand it and you can see tables. If you expand that, you can hit new. And you can start defining your table without having to know all the syntax. So if you guys want to create this table, do you guys want to create the recipe table or do you just want to keep going with the flow? Because I have... Okay. So I have a recipe table. These are the fields that we want to go in it. We're going to want sorry, I keep thinking that's something else. This one. All right. So we're going to create a table. Put it in the other one. We're going to call it recipe details. It's going to have 1, 2, 3, 4, 5, 6, 7, 8 columns. So if you've got only 4, I think, which is the default when you bring it up, I think there's a little button on the bottom right that says add more columns. All right, the first field you want to call it recipe ID. That's going to be our primary key. And the data type, you want it to be an integer. Certain databases, well, all databases handle numbers a little differently. MySQL is it's very particular about numbers that you use. With Oracle, you can just say something's a number and it will be a variable length and you can fit 1 to a billion in there. If you have MySQL and you say it's an integer, An integer is 16 bytes and only can go up to 16,384, I think. So that will be the max value that you can get in there. For a recipe database today, that's not a big deal. If you are working with larger data sets, you want bigger integers. And if you click on the type, it will tell you what the range is on what you can use for that field. For length or value, for integers, there's no length or value. It's just an integer. Default, you don't want anything. You don't want it to be nullable, so you can click that. You leave that blank, sorry. Auto increment, that's what this AI is. This is gonna be our primary key. So you wanna hit auto increment, and it's gonna pop up something. This is gonna tell you that it's essentially creating an index. The way that it keeps track of primary keys and foreign keys is that it creates another index on those objects so it can keep track of all these unique values. You can use a default name, don't have to change anything. If you were building something that you wanted to be able to keep track of and you were working with multiple users, you could put comments in there and you can just say this is the primary key, or you can say whatever you want. All these comment fields allow you, or they let you describe the database that you're building so that someone else can go in and figure out what it is without having to know what's going on. The next column you want to put in is the recipe name. You're going to want this to be some kind of text field. So you can either use a varchar, which I'm not sure how different PHP or MySQL treats text and varchars. I think what the deal is that texts or varchars are for values that are going to be 4,000 characters or less, if it's like Oracle. Text fields are going to be anything you want longer than that, but I imagine that for this case it doesn't matter. So for this one, you're going to want a length. Varchars are variable character fields. You need to give it a length, so this will be a max length of the recipe name. 30, 20, whatever you guys want to use. No other values? You don't need any other the fields for that, unless you also wanted to use a unique key. If you wanted a person to be able to submit one recipe at a time, well, not one recipe with a given name at a time, you would put a unique key on this table.
So that's what it means?
Yeah.
Unique key?
Unique key means that whatever columns that you put that unique key on, all the data that you have to put in there is unique. If you put a unique key on just the recipe name and you went and put in bread and I put in bread, it would yell at me and say you can't put in bread because it's already there. But if you put it on a recipe name and the author, you could put in bread, but if you tried to put bread in again, it would yell at you.
So this would be different from bread. It can be like a bread.
Right, it could be uppercase or lowercase, or wheat bread is fine. Or,
so it does matter, uppercase and lowercase?
Yes. Databases are case sensitive. It depends on how you handle data. Some databases, people take whatever you're putting in and will convert it to uppercase or lowercase, so it standardizes a name. But yes, it is case sensitive. You're going to put in author, which is going to be another character field. You're going to do a description, which is going to be a longer text field. So if you think that anyone's going to put in more than 65,000 characters for a description, which is a pretty long field, then go with the text. Otherwise, keep using a varchar. All right, so we also now have the 4 numeric values that we have to worry about. We have prep time, cook time, ready in time, and rating. For these, if you want to be able to have a 15.5 minutes, you have to make sure that you allow for decimal values. If you only want whole values, stick with integers. When you're using a decimal, you also have to provide a length, and it's going to be a 2-digit or a 2-number length. So if I say my ready end time is a decimal value and it has a length of 10.2, it means it can take up to 10 digits total, 2 of those being in the decimal place. So if you try to stick in 10.0005, it's going to either truncate depending on the database, or it's going to say you can't stick that in there, it's not a valid value. I think in MySQL's case, it's just going to round the value off that you stick it in there. Rating. If you want them to be able to have 4.5 stars, you need a decimal. If you only want them to have 4 or 5, but no in between, stick with integers. All right, so just the way that MySQL's set up, it has different ways that you can store data. It has different engines that run under it. The default is MyISAM. This doesn't support primary foreign key relationships. So what you're going to want to do is change that to InnoDB, which does support foreign key relationships. If you wanted to put a comment on the table, this is the header information for your recipe. It's the same as the column comments. Now, why I said you don't need to learn SQL is because you have this set up, but you also, in most tools, have a preview SQL button, and it will spit out what it's about to do for you. So when you want to save what you've done so you can redo it without having to go back to the screen and retype stuff in again, you can just copy this, save it off somewhere, and then run it in a command prompt later on. So you're going to save it. And hopefully it takes you to a screen that shows you the table structure that you just created. I know with yours you're going to be a little different because you're using a little more in-depth tool. So if you go to browse now, this will show you what's in the table, which is nothing, just as expected. You guys all have internet access? If you want to grab the 2 other create table statements off of my Google Drive, I shared it to the Facebook event. So that way you won't have to do this again for the second 2 tables. Discussion. All right, and here's going to be a file called create tables, I believe. Create tables.ddl. You've already created the first one. You can just take the second one, copy it. Down at the bottom left, if you're using WAMP or MAMP, there's a little button that says console. This will bring up a command line for stuff. For putting in SQL prompts manual or SQL commands manually, you can just paste that value that you just did in there and hit Control and Enter, and it should run. Yeah. And you can run this third one for directions. You should get a nice little checkbox that says MySQL return an empty result set. That means it did an error, so you should have these tables now in your database. Were you guys able to create those, or? Okay. If you go to the event, and if you scroll back up where the discussion is, were you guys able to get that stuff, the two new tables in? It might not show up in the browser off to the left. If you click on the name of the database that you had, you'll see that it shows up in the list of structures, but it doesn't show up over here. You might have to just refresh. And there it is. So you should have these three tables: directions, ingredients, and recipe details. Yes, no, maybe so. Okay. All right. So that's why I said you don't have to listen to, or you don't have to memorize any of this stuff. But you want to keep in mind how this stuff works. Essentially, to create a table, there's a statement that says create table. You give it some details, poof, it creates a table. Or you go into your favorite SQL tool and go through the GUI, have it create it for you that way. Once you create the table, it is not set in stone. You can alter the table. You can add columns to it after the fact. You can add columns, you can add indexes, you can add more constraints, you can drop them. You can disable all your primary and foreign keys so it stops checking. You probably won't want to do that on the regular, but if you're doing some kind of maintenance where you're moving a bunch of data around and you know that at one point, until your script is done, everything won't be in sync, you can disable your keys to keep the data moving around. In the end, you're left with what we consider a data model. A data model is just all of the tables that you're using in your database to perform a certain activity. In this case, it's the recipe with its children, the ingredients table and the directions table. If you may notice that the PHP MyAdmin page was a little wonky. It's a pain in the butt to use. There are other tools out there. There's MySQL Workbench specifically for MySQL, which will let you actually draw a table and put columns in and indexes. Oracle has their own SQL developer. Irwin, I think, is now free. This is the industry standard tool for doing data modeling with. It used to be hundreds of dollars, and now I think they have a community edition. PHP MyAdmin kind of has this capability as well. If you are in your database and you go to tables, there is somewhere I'll find it later that lets you look at data in a relationship. So what it's going to do is draw your tables out there, but I don't remember exactly where it is right off the top of my head. Oh, there it is, sorry. Relation view. Not what I was expecting to show, sorry. I'll find that later and let you guys know. But essentially, there is a way in PHP MyAdmin to create a diagram of all the tables in your database. In the case of this recipe, it's not a big deal, it's 3 tables, but in real live databases where you're actually doing stuff, 10, 15, 20, 30, hundreds of tables, and you're not going to want to know every column. You're going to want to be able to look at it from a large view perspective and see what's related to what without having to dig through DDL. And I know we kind of glossed over this, but the core of your database being successful is how good of a data model you build. If we started with that first set of data that we had and we just crammed that all into a database, you can't change your units of measure. You can't sum up how many loaves of bread you have recipes for, how many cups of sugar, all the stuff that you want to have a database be able to do. You can't do if that's not all set up nicely. All right, so we have our empty database. You want to be able to insert stuff into it. Same thing as before. You're going to insert into a table. You're going to give it the list of columns that you want to insert values for, and you're going to give it a list of values. But you don't have to memorize that. You could go back into Browse. Make sure you have the table that you want, recipe details. And there is an insert right there. This will let you manually start putting in values in the database. Don't put in recipe ID. This is the auto increment primary key. It will put in a value for you, so just leave it blank. Recipe name, you can call it whatever you want. Bread. Bob made it. Really good stuff. It only takes them 5 minutes. It's a really good recipe. But it tastes like crap. You put the values in, you hit go, it gives you the SQL that it ran, and hopefully up top it'll say 1 row inserted, and it gives you the primary key value that it assigned to that table. If you go back to Browse, here's the crusty white bread that I had originally in there, and this is the new bread value that I just inserted. So I think you've caught on that you have to insert more data now. I did stick in the shared drive an insert statement for all the instructions for the crusty white bread that's in there. So if you wanted to go grab the insert script out of there, insert data.sql. I put in the recipe, ingredients, and directions. You can just copy this in and paste it in before, like you did before. It also assumes here that the value that you just put in has a primary key value of 1. I hard-coded it in instead of coming up with a script that stores that value. So if for whatever reason you didn't come up with 1 as your primary key, just make sure you swap these out with the value that was actually used. But it should be 1. If you get that little red thing, it means there's a syntactical error. There might be a period there, change it to a comma, and it works. All right, were you guys able to get all of the ingredients and directions in? I'm gonna take silence as a yes, or sleeping and don't care. All right, so we've got a database, we got data in it. Now we want to be able to search it. Very simple command. Select list of columns that you care about from the table that you want. This one you also don't have to memorize. If you go to search, SQL, it already gives you the basis of the SQL that you want. So get rid of that. Where 1, the default that it gives you, it just means give me everything, but that doesn't really mean anything. You can get rid of it. Select star from directions. That gives you everything from the directions table down here. But that's boring, like databases. You want to be able to filter on that stuff. So with a query, you could define a where statement. This now lets you start putting in conditional statements, like saying, I only want ingredients where the units of measure are cups. I want users that are over the age of 57. Give it to me in a ordered list with a specific order based on column names. So if I take that and just run that, I'm now getting all of the ingredients that are measured by cup in the order of the ingredient name. Because I put bread in there twice, or 2 different breads, I got everything repeated, but it's all the same ingredients. some things you're not going to care about until later on. You can alias things. So if you wanted ingredients name to return as something else, just call it ing. You could put as and then the name that you want that column to be displayed on as your query results. When you're going to do this is when you have multiple tables with the same column name and you want to be able to differentiate them between in your results. So if you have the primary key value, recipe ID from ingredients, and recipe ID from the directions table, and recipe ID from the recipe details table, if you don't alias them, the only way to tell them apart in the results is knowing the order that you selected them in. An optional parameter when you're selecting stuff. With MySQL, you can have multiple databases, and you can query across multiple databases. And when you are selecting stuff from multiple databases, you have to put the database name in there. So that way, when you're querying, you're connected to one database. You go out, and you say, I want to get it from this. You put the name in there. You can alias table names, which will be more helpful when we get down farther. I'll show it to you. You don't need to include it when you're, like in this, you don't need to include the table name here. But the actual Oracle syntax is ingredients dot ingredient name. It gets to be a pain in the butt, so most people shorthanded that to not requiring a table name when you're putting in a select statement if this column name only exists in one table. If you have it in multiple tables, you have to alias it. But I'll show more details of that where it actually is relevant later on. Where conditions. You're not restricted to just saying, this column equals this. Anything that you could do in a select clause, you can do in a where condition. So you could say where units of measures are equal to something, you can provide it a list where of units of measures are in, give me some values that you want to use. When you're comparing something that's potentially nullable, there's a command for is not null. So that will find you all units of measures that are not null. The opposite of that would be is null. So if you want to find all recipes that have null units of measure, you would do that. You can combine things. You say where this is equal to this and quantity is greater than 3. So these are essentially Boolean operations that you can put in your where condition. You can nest them. You can put parentheses around multiple or statements and statements and create complex logic. You can use between if you're using numeric values. These are inclusive in most databases. So when you say between 2 and 6, it's not 3 to 5, it is 2 to 6. And you don't have to make sure, or you don't have to make, they don't have to all be the same data type in your query. So you can say where quantity is 3 and order equals 1, and you have an ingredient that's like pork. Whatever your query conditions you want, you can use, as long as it's valid SQL. You can also insert into tables with select statements, which is helpful if you're trying to create a subset of data to do analysis on. Or if you have a recipe that you wanted to copy and give to another user, you could create a select statement that says select all the columns except for author. This is the new guy's name. And you can insert that data into the database, and you now have a copy of your recipe. Once your database has been loaded with data, you can change the value. It is not static. The command to do that is update. You're going to update your column or your table name, and you set the column name equal to what you want, and that where condition, which will identify what rows are going to be updated. Ideally, this is your primary key, so you say, I want this recipe to now have a rating of 3. You could say, I don't like pork. I want all pork recipes to have a rating of 3, and change the where condition so that it looks for pork. There is no restriction on what you can and can't update. And the same thing for getting data out. Delete from table, where some kind of condition. So where recipe ID between 1 and 100, we'll get rid of the first 100 recipes that are in the database.